Hello students, let's look into this problem. Using mathematical induction, prove that sum of squares of first n natural numbers is n into n plus 1 into 2n plus 1 by 6. Okay, so now let us solve this. Let us look into the solution. So, what did we learn about mathematical induction? It has mainly 3 steps. The first step is substitute that n equals to 1. So, when n equal to 1, s of n equal to 1 square, nothing but 1. According to the formula, s of 1 is 1 into 1 plus 1, 2 into 1 plus 1 by 6, which is nothing but 1 into 2 into 3 by 6, which is equal to 1. Therefore, s of n is true for n equals to 1. Now step number 2. Step number 2 is nothing but it is an assumption. Assume that s of n is true for n equals to k. S of k is true. Now replacing n equal to k, we get s of k equal to 1 square plus 2 square plus 3 square plus so on up to k square. And s of k equals to k into k plus 1 times 2k plus 1 by 6. Now the main step number 3, is nothing but we have to prove that s of n is true for n equal to k plus 1, the next consequent number of k, where k belongs to natural number. Here also k belongs to natural numbers n. So let us see how to prove this. Now s of k equals to 1 square plus 2 square plus 3 square plus so on till k square, right? So what is s of k plus 1? It is equal to 1 square plus 2 square plus 3 square plus so on plus k square plus k plus 1 whole square. Because k plus 1 is the next consequent number for k. So, as we know, according to our second step, according to our assumption, we replace the sum of first k natural numbers. It is nothing but k into k plus 1 times 2k plus 1 by 6 plus k plus 1 whole square. Now, s of k plus 1 is nothing but k into k plus 1 times 2k plus 1 by 6 plus k plus 1 whole square. We get k plus 1 as common. And we get k times 2k plus 1 plus 6 times k plus 1. So, it is k plus 1 2k square plus k plus 6k plus 6 which is nothing but 2k square plus 7k plus 6. Now look at this equation. 2k square plus 7k plus 6. This can be written as k plus 1 times 2k square plus 4k plus 3k plus 6. Now this can be written as 2k as common here, k plus 2 plus 3 common and k plus 2. So here we get, okay, by 6. Here we get that k plus 1 times k plus 2 is common again and 2k plus 3. So the one inside the bracket, we could come to this form, k plus 2 times 2k plus 3. This is nothing but k plus 1 times k plus 1 plus 1 and 2 times k plus 1 plus 1 by 6. So S of n is true for n equals to k plus 1. Therefore, as we can see, first we could prove that sum of squares is true. This formula is true for n equal to 1. And by assuming that sum of squares of first n natural numbers is true for some natural number k, we have assumed that this is a true statement. Now we are trying to prove for k equal to 1. So by following these steps, we could conclude that S of k plus 1 is also true. So when a formula is true for two consequent numbers k and k plus 1, then it is true for all natural numbers. Therefore, S of n, which is the sum of first n squares of first n natural numbers, where n belongs to n, is true for all n belongs to n. Therefore, this is a true formula. So using mathematical induction, we could prove that sum of squares of first n natural numbers is n into n plus 1 plus times 2n plus 1 by 6. So using this formula, we can get sum of squares of any natural numbers starting from 1.